Okay, so we're going to define what we mean by a congruence class. So the congruence class of a number a mod m, okay, so obviously got to specify whether we're working congruence, modulo, whatever. So the congruence class is the set of all numbers b that satisfy a congruent to b mod n. Okay, so it's just the set of all the numbers that when we do a minus b, that n divides that. Okay, so that's a nice and simple definition. Note for a start that the element itself is in its congruence class, because a minus a equals 0 and n divides 0 for all n. Okay, so that's a nice and simple one. I did a video on congruence classes proving that if two congruence classes share any elements, they're actually the same congruence class, so I'll leave that linked in the cards. But yeah, that's a nice simple proof, so don't worry about that. But anyway, this idea of the congruence classes kind of follows on from what we did at the end of the last video, modular arithmetic, because it shows that an integer a is congruent to infinitely many b modulo n. Alright, so you can pick and choose between these where required. So let's do an example. So let's do an example. We're going to work mod 3. So what are the congruence classes here? Well, we're going to keep going, and then because I said if elements share any elements, they're actually equal congruence classes. If we realize that by creating a new congruence class, it's got any of the elements that are in the previous congruence classes, we're finished then, because we've found all of them. So if we do it in this systematic way. So the congruence class of 0 is the set coming down from the negative end, minus 6, minus 3, 0, 3, 6, carrying on, 9, 12, so on. And in this way, minus 12, minus 9, minus 12, so on. Okay, hopefully you can see this, because 0 minus any of these numbers, 3 will divide that. Okay. Now, congruence class of 1 is equal to minus 5, minus 2, 1, 4, 7, so on in threes, like so. We've just added 1 to each of the elements above. Sorry, this should be continuing. Okay, and again, you can check this. Minus 5 minus 1 divides 3. Okay. So that's all nice, and 1 minus minus 5, 6 divides 3 as well. So obviously it works both ways. I think we proved that in the last video. But yeah, so that's another one of the congruence classes. And then mod 2, not mod 2, the congruence class of 2, mod 3, comes in, and it's minus 4, minus 1, 2, 5, so on. Okay, now if we were to take the congruence class of 3, you can see 3's already in the congruence class of 0. So this actually is not a new congruence class, and we found all the congruence classes. When working mod n, there will be n congruence classes, okay, which makes sense, because you've got n different options for the remainder, either 0, 1, 2, all the way up to n minus 1. Okay, and that's n different possible combinations. So like I say, we can write any representative, use any representative. So congruence class of 2 is equal to the congruence class of 8, is equal to congruence class of -4. Okay, just often choose the simplest one. Another thing, we want to get used to this notation. Obviously 3 can be interchanged with n, but this is the set of the congruence classes, so this here is equal to this. Okay, but we often don't write the square brackets once it's obvious we're talking about congruence classes as opposed to numbers. Okay, and then it's just sort of assumed that we're working with the congruence classes, so we could write that just 0, 1, 2, and also that set could be written as 3, 7, -4, but we try not write things in weird ways, and why would we do that? But just to illustrate the point, we could write it like that. So yeah, that's what we're going to cover in this video. Hopefully this gave you a nice idea of congruence classes. We're not going to go much further with congruence classes until maybe we go back onto some sort of group theory, and we'll compare this with other mathematical objects we can get. So thank you for watching. We'll look at some more congruence mod n in the next couple of videos, and then we will do some we'll go a bit more in detail with the modular arithmetic, and that's it. Yeah, so thank you very much for watching, and I hope to see you